and Docker stuff at Confluent. I've been there about 2 years. I've worked on deployment and monitoring systems at various companies throughout my career. At Confluent, I helped put KSQL in a Docker to begin with. Most of my experience around KSQL has just been around like packaging and deployment. So I'm not like a developer on the team or anything. I'm a release engineer at Confluent. I'm still kind of crash coursing my way through Kubernetes and learning how to do things. I just happen to really like KSQL. It's one of the projects that got me fired up to join Confluent. I'm excited to see it get deployed widely, and I'm happy to be here evangelizing it a bit. I was going to have a what is Kafka, but thanks George, because we probably know what it is by now. Most of us here probably know what Kafka is anyway, and you might even have one running somewhere. You might also know a bit of SQL, and you might also know how to run a program on a computer. That's pretty much all you need to know to get started with KSQL, because that's what a KSQL application is. It's just a set of streaming queries running in a continuous manner across a set of servers. You've probably heard of KSQL at some point, but just in case, I'll keep the introduction brief. The demo and preview builds have been out for a while now. We just moved KSQL into Confluent Platform, which is our kind of like a software distribution that we have around Apache Kafka. We think KSQL's pretty much ready for production. Under the covers, KSQL was built on the Streams API, the Kafka Streams API. A KSQL server is actually just a Streams application, and it's also working with some of the lower level consumer and producer APIs. So it's just a Kafka client, reading from and writing to topics. I'm excited about KSQL as a technology because I think it really has the potential to simplify infrastructure. I've worked on, at various places like freeloader databases, I call them. Their only real function in life is just to soak up change information from, it might even be from Kafka. I feel like those sorts of databases, like these are the kinds of databases you would use like in a deployment or a monitoring system where the most recent data is really all you really care about. I think that those types of databases could just go away. And sometimes there's also a REST front end to that database. That REST front end can also go away. Sometimes there's a custom client that you've written to access that REST server, and that client can also go away. We end up in a world that has fewer moving parts, fewer single points of failure, and fewer sources of latency. KSQL works on the concept of continuous querying. You can't really see it, but they're just I'm just showing it's SQL. It's basically just a SQL statement. The big difference is when you run a normal SQL statement in MySQL or whatever, your query runs, it spits out some data, it exits, it's done. When you issue a query in KSQL, it hangs around. It doesn't go anywhere. You are actually, so instead of writing lower level stream processing code, KSQL lets you actually build out your application logic just using SQL. It outputs continuous streams of transformed data from one topic into another topic. The stream queries don't stop unless you stop them with hitting Control-C in the command line, or you can have natural limits on them too. So if we're going to be deploying KSQL, it helps kind of to have an idea about what the cluster looks like. We like to know what's going to be talking to what. KSQL ships with a CLI for issuing interactive queries, and a server component where the query processing actually runs. I'm going to focus mostly on the server component, but I think it's good to just have a general idea of the different pieces and the various modes of operation that you can deploy KSQL under. In KSQL, all servers in the pool share the processing load. Servers are just all instances of the same Kafka Streams application. So you can, they can be scaled up and down without a restart. Pretty much all of the same operational considerations that apply to a Kafka Streams application apply to a KSQL application. So I mentioned there are different modes of operation. We call this one interactive mode, as you can see. It's also, we've had various names for these things. We call it like client-server mode internally. It feels like it feels a little sandboxy to me, because what's going on here is the CLI is connected to one of those servers, and you might also, the picture doesn't show it, but you could have multiple CLI too. Your CLI is connected to one of the servers. You're issuing queries, and these queries are actually, they're creating new streams of data. They're doing a significant amount of work. And the reason it feels kind of sandboxy to me is because I'm kind of like used to databases. I'm like, I feel like, would we really add a new continuous query on an ad hoc basis to a production cluster? That seems kind of sketchy. I could see it being really powerful, but hard to budget for. I guess you can kind of like, you could establish like an upper limit on how many queries you're going to be running or something and budget it that way. I could see this being useful for like data exploration or testing out new queries before you ship them off in a more concrete form to production. But I personally just wouldn't use this to modify a production cluster. I wouldn't feel comfortable with it for the same reason that you wouldn't want to do like an update statement on a production database. You just don't do that. This sort of setup is ideal for local development and poking around in a sandbox cluster. The server itself listens with HTTP, and it's just a REST server, fairly well documented, actually, which kind of opens up the possibility of non-Java clients. Like, just picture like a Python application there instead of KSQL CLI. It is possible that someone's going to do that. I totally expect it. But the REST API, if you do like have a reason to get at that, it is documented and it is accessible. Well, seeding into a directory and launching Java processes directly on your workstation isn't really what we like to think of as deployment, but I'm going to start there because we wanted to make that an insanely easy way to get started with KSQL. We want everyone to feel what it's like to be the person pictured there who is actually very excited about KSQL and isn't like doing a table flip or something. They're happy because they just got started with KSQL in a few easy steps. You really just have to grab Confluent platform, use the included CLI to start it up. Confluent start is a single command you'd run to get like one instance of everything, including KSQL server. You would connect to the server with the KSQL CLI, and then basically immediately you can start doing stuff. But caveat there is obviously in a brand new fresh cluster that you just stood up on your workstation, there's not going to be any data there. So if you are interested and you want to try, get your hands dirty on KSQL, you can kind of follow these steps. We have a quick start on our site. Just go to confluent.io, and our quick start expands on these steps, but you'll actually get like live mock data flowing through the cluster, and you'll be able to like see it in action. And then don't forget to use Confluent destroy to tear down your cluster when you're done. Someone working in a development capacity might use interactive mode to prototype an application in this way. You can see these are just, and don't obsess over the details of the queries or anything. These are just, it's a contrived example, but you can see that they're starting up these persistent queries. Clearly, they've thought about their queries a bit and their data model a bit ahead of time. They're not just making this stuff up as they go along. They've really thought about how they wanted their joins to work and stuff. But still, this is a really quick and convenient way to prototype your KSQL application, and just to see if everything is working as expected, if your data is showing up in the topics that you expect, and everything. So. It's worth mentioning that there is this explain statement available. It gives some insight into what's happening with a particular query. The runtime metrics shown there by the explain query are also exposed via JMX, so that you could plug them into a monitoring application, or your whatever your JMX application of choice is. I'll have some more examples of what you can do with that stuff later. So now we're moving out of contrived deployment land and we're starting to think about an actual deployment. Like, we're going to need to configure KSQL Server. There are only a few mandatory configuration parameters. KSQL basically just needs to know where Kafka is running and what port to bind to with its REST interface. Quite a few optional parameters, though. The really important one there is the service ID, which determines the pool that it's going to be sharing workload with. So all the servers that have the same service ID are going to shard processing for your query across them. You can use any, I'm not going to read the slide, but because KSQL is a Kafka client and a streams application, any producer, consumer, streams property can work there. And the real world application there that you're likely to run into most often is like security, if you need to connect to a secure broker. I added a note about Docker there. We have some new Docker images for KSQL, and they follow the same convention as Confluent's other Docker images, which is just to prefix the property with the component name. So you just pass these in via the environment, and the Docker container will do the right thing. So hard problems in computer science. Something has to run this command somehow, preferably not by hand. We don't recommend running the Confluent developer CLI on production hosts, and we don't really advocate going around running KSQL Server start by hand everywhere either. So the KSQL Server start command would be applied to something like an Ansible runbook or Docker file entry point, or wherever you happen to codify the startup control for your application. You just provide, one way or another, that server properties file. If you're using the Confluent image, it's already baked in there, and you just need to pass in some environment variables. But that right there is starting up KSQL Server in a nutshell. As mentioned earlier, KSQL does expose metrics via JMX. If that JMX port environment variable is set, KSQL will use it. The top level metrics provided by KSQL are all pretty good things to monitor. There's, I don't know if you can really see it there, but there's, like bytes consumed, error rate, messages consumed, messages produced, number of queries. You would just basically plug those into your monitoring system of choice. And in addition to these top level metrics, there are also per topic metrics. There are metrics for your input topics and your output topics, which are just kind of like more granular than the top level metrics. If you were running KSQL for a particular project or for a particular team and they had a dashboard for their project, these would be a great thing to just throw up on that dashboard. So this is what you need. I should have used a brighter shade of gray, but live and learn. This is what a KSQL application looks like. There's supposed to be arrows coming out to the tags. These are get tags. And essentially, it's just a file with a bunch of queries in it. We can think of a KSQL application as a set of queries that are running to accomplish a desired task. It's likely that everyone's going to have the queries checked into a source repo anyway. After you go through the process of prototyping your application in interactive mode, and you figure out what queries you actually want to be running, and so you'll get those checked in, presumably. And starting from that, you can ship an independently versioned application. Independently versioned and independently deployable. So you can scale it up, scale it down as needed by itself, just for this particular use case. Pretty much cutting a release tag like you would for any other deployed application. Now you might decide, we still don't really know what a KSQL application is going to look like in the wild, but you might decide that you want to ship other deployment metadata along with it. So in this repo, alongside the query file, you might have something like chef habitat config, or like a Kubernetes chart, or that kind of stuff, just to help stuff that's supposed to ship with it, stuff that's supposed to help get it out the door. But that queries file is the basis of KSQL's other mode of deployment. You see that this slide looks quite a bit like that first slide I showed, but instead of a CLI connected, we have got just a bunch of SQL files being read by each server instance. Excuse me. I think this mode makes the most sense for production. It's more deterministic. It's more like hermetic. There aren't a lot of things poking around at it. It's just like the server runs with its canned set of queries, and that's all it's going to do. And you can budget for that fairly effectively. In this mode, KSQL is just running those canned queries from a file, which is ideal for something like an ETL pipeline with managed version-controlled queries. In this mode, you just, when you start up KSQL Server, you just pretty much have to specify the path to that SQL file so it knows where to find it. Also in this mode, it's worth pointing out that the REST endpoint is turned off because we don't want people connecting to these server instances with the CLI while they're doing, a planned workload. Like, we don't want fingers poking around in there. So, more hard problems in computer science. Something somehow has to make that query file available. And unfortunately, I had more stuff in the slide, but it's gray, and the projector is not capable of showing the shade of gray. But live and learn. Bonus points if your query file actually has valid stuff in it and is readable. But in a way, this is good because it's just showing like a single instance. What you can't see, and is too light on this, is just more of these. So this is like a real-world deployment of KSQL where you're going to have multiple instances of KSQL Server, and you might even have them like, you might have this group of instances, which is a separate pool from some other group of instances up here, because they're running a different workload. You want to be able to scale those in and out independently and deploy them independently. So Confluent provides an image for KSQL Server, and we think it would be great to use that as a starting point. There's going to be more than one way to get that queries file into the container. You're going to have to pick one. I thought of a few possibilities. You could, for example, treat it just like another form of config file. I'm talking about this queries file here. And let whatever config management system you've already got running in-house take care of it for you. You could bake it right into the image on another layer, just like take the Confluent KSQL Server image and just add another layer to it. That's one possibility. You could mount it right inside the container somehow. In Kubernetes, this thing called config maps seems like the way to do that. You could have your container, like fetch the SQL from a URL on startup, or any number of other fun, creative, wacky solutions. The possibilities are endless. When I sat down and went through these steps, I just decided to go with the config map approach, since that's pretty normal for Kubernetes. In this style of deployment, the JMX exporter, you can see there, is running in a sidecar container alongside KSQL Server. This is why in, well, you'll see in a few slides here, this is actually running in one Kubernetes pod. And so there's two containers in that pod. They are deployed together. Yeah, for when I was stepping through these, when I was stepping through KSQL deployment on Kubernetes, I checked in the queries file alongside a Helm chart, Kubernetes chart, which is just a way of representing your deployment. It's like all of your deployment metadata. Just because I wanted those things to be versioned and shipped together in my application, but really it could be checked in anywhere that makes sense for you. And I mentioned Helm, and so here is just like a quick little snippet from the Helm website. Helm.sh is their website, and Helm is just a tool, for those who don't know, to manage your Kubernetes instances a little easier. It's the way, I think. I'm digging it, but if you're curious, check out helm.sh, and it will give you way better information than I could. All I had to do when I was getting the cluster up and running was just run helm install, and I gave it the path to my chart, and it just brought everything up, and I was thrilled. There's the command I actually ran. I think that's supposed to be 2 dashes, but it got turned into a smart dash. I did run into a little bit of bumpiness along the way, so I feel like I should be straight up and give a couple of bleeding edge warnings to set expectations, so you'll know what you're going to be running into. If you like want to go home and do this right now. I deployed the Confluent pods shown here by running helm install with Confluent's charts, and then I ran the charts that are freely available out there for Prometheus and Grafana to just have some monitoring in my cluster. They just came up with no fuss. The gotcha there is Confluent's Helm charts aren't available yet because we are waiting on some signatures, lawyers, right? But any day, any hour, I think we're gonna be able to flip the switch on GitHub and open these up. Another gotcha is we say KSQL is production ready, and we think it is, but the Docker image I was using had a bug with metrics reporting. So to see this actually work end to end when I was going through this just a few days ago, I had to real quick spin up my own images. I cut them from the trunk branch of KSQL and Kafka because I knew that the fixes were in, and it turns out being a release engineer at Confluent has at least one advantage. I can do that. Anyone can make your own Docker images, and I'm well aware of that, but what we really want is for people to use ours, and we want to make them as good as we can, and as of the time of this talk, we owe you a KSQL Server image with not broken metrics, and we will get that out as soon as we can. Another thing worth mentioning is, like, if we were able to open source our Helm charts today or tomorrow, the KSQL Server chart isn't in there yet. It's I've got a pull request open for it, but I had to write my own. I had to cobble together my own really quick for this demo just so I would be able to see what KSQL looks like on Kubernetes. And I'm still pretty new to like Kubernetes and Helm, so if I can do it, that kind of bodes well for Helm as a technology. I think pretty much anyone can figure it out if I can. And we're looking at something closer to an actual deployment here. But what's pictured is still kind of just like a minimal set of services. I've only got a single KSQL server instance. I think in a real world situation, you would have multiple KSQL servers, and not only that, you would have multiple pools of them. Additionally, you would be probably, I know this is hard to see, but this is just like pod name with some random garbage at the end, because that's the instance ID. I'm also running Kafka and Zookeeper in this Kubernetes cluster, and they don't have that garbage at the end. They've got real numbers like 0, 1, 2. That's because Kafka and Zookeeper are part of what Kubernetes calls a stateful set. And in a stateful set, the instances persist, I guess. They don't just evaporate when you shut them down like the normal instances do. They've got attached persistent storage, and so if you have any kind of state, any kind of cached state on the node, you probably want to be using a stateful set. KSQL Server, I think it'll work outside of a stateful set. All of its locally cached state is disposable. It's not going to be the end of the world if it loses it. It'll just rebuild it from an internal topic that it has, a changelog topic that it keeps. But keeping a stateful set would just speed stuff up. It'll speed up cluster restarts and that kind of thing. KSQL Server is pictured here alongside Kafka in the same Kubernetes cluster, but it doesn't have to be. You just point it at wherever you've got a Kafka running, your own in-house Kafka, or a plug for Confluent Cloud. Check out Confluent Cloud. Self-service. And I mentioned earlier that I had set up Prometheus and Grafana, and unfortunately I didn't have enough time to get like mock data gen running, so these are totally flatline graphs, but they're legit, I promise. This is actual data. It was really easy to get Grafana and Prometheus up, and the reason I chose those is just because it's what everyone's using, and it was really easy to get going. It was no fuss at all. I started up my server instance. It exposed the metrics to Prometheus, and Grafana scraped those metrics from Prometheus, or whatever the right terminology there is, and I just had to click around in Grafana initially to import the dashboard, and it was super easy. What I found while learning Kubernetes and Helm is that there is a learning curve there for sure. It's really complex. There's a lot of YAML, but effortless deployments are kind of priceless. It really won me over with just how easy it was once you're actually there and using it. It took 3 commands to deploy all of Confluent Platform and Prometheus and Grafana. Another command to like open up the Grafana UI, and then just like, a few clicks in Grafana to get it all going. Real world deployments are gonna probably have a little bit more configuration, especially with regard to security. But this is just a really good way to fly, and I can see why this solution is loved by so many. I had a really good time working through these issues, deploying KSQL on Kubernetes actually, and even though I'm still just playing in a sandbox, I really do look forward to seeing large-scale deployments out there, what they're going to look like, and I just want to see KSQL in action. What's one of those? Capacity planning. I wish I caught the animation. Okay. I'm not going to go on too much about capacity planning. There are lots of factors, and there really is no one-size-fits-all solution. That said, we have really good guidance in our docs. We have really good guidance, and not only guidance specific to KSQL, but because KSQL is built on the Kafka Streams framework, the same scaling principles for a Streams app apply to KSQL, so you can take a lot of those principles, just carry them over. If I were getting started with a KSQL app, I guess I would start with like the minimum recommended cluster specs and work out from there. KSQL, consumes CPU to like serialize and deserialize messages, so the harder it is for it to do the serialization, deserialization, the more expensive it's going to be. Something like JSON, more expensive than something like Avro, which is optimized for going out across the wire. And then obviously whatever CPU processing is required to actually do the message processing on each node. We recommend at least 4 cores, and the reason for that is because there are, I think, like 4 threads in your KSQL process, and you don't want to starve them out. KSQL does use local disk a little bit to persist temporary state for aggregations and joins, and that's the I mentioned those earlier. But for that reason, we recommend you run it with an SSD. So you probably have to, if you're running it in the cloud, ask for like a custom instance site or the type of instance that has SSD storage attached. Finally, and I kind of push this towards the end just because it's worth a mention, we have a pretty nice UI for KSQL. It is part of Confluent Enterprise. You can, it's actually part of our product called Control Center, Confluent Control Center. You can create new streams, you can write queries against existing streams and tables. This screenshot's kind of old at this point. It's even nicer than this, but our Control Center engineering team has been working really closely with our design team, and they're building something very nice. That's pretty much it, though. I saved the download links for the last slide. If you want to take a picture of it or something. Yeah, we just wanted to make it really easy to get going. So those are our new CLI server images. Yeah, that's pretty much it. I'll open up to questions if anyone has questions.
For the Confluent, do you guys also offer some university trial and licenses for universities to try it out? This is in general, because I'm not familiar with your product, I guess.
Well, we have the open source product, which doesn't require a license. I don't think we have a university trial. I brought Nick Dearden with me. He knows more about this stuff. Do you?
All of Confluent is free for anyone to try for 30 days, including enterprise capabilities, regardless of academic status or whatever.
Right, and so, yeah, Nick's answer there is, even our enterprise stuff is free for anyone to use for 30 days for evaluation, but I don't think we have a university thing. That said, I think you can get a lot of value out of the open source. Anyone else?
So
yeah.
How are the aggregations done? So let's say like I want to know the number of messages sent by a user. So I want to group by that user ID, and I want to know so within the queue, if I have to do a group by, and that is ever changing. So how do you run the group by queries?
I probably can't answer exactly what's going on with the queries under the covers. There is when you write the query, there's I guess, are you wondering about the windowing range, the time range that you're going to be joining on, that kind of thing?
Right. Sometimes it could be time range, but some of the queries may not be time range. What do you do if it's not time range?
I actually don't know the answer if you're not using a window, but in the case that you are using a window, it's just, it will just naturally line up. Right.
Yeah, if it's a time window.
We do have, there are a few different windowing options that we kind of explain in detail on our doc site. Yeah.
Does the KSQL server also support Kerberos?
Does it support Keros? Because the question is, does KSQL server support Keros? In connecting to the broker, I assume you mean.
Yeah, or even the CLI if I want to do
I don't think that it does today, but if you need to connect to a Kafka broker, you can that way because you're just using the normal producer-consumer connect property. Am I right, Nick? I'm right.
Yeah. It's built out of Kafka clients. So anything you can do with a Kafka client, it can
That's right. Anything you can do with the Confluent client, you can do with KSQL server. Anyone else?
And let's say like I have like 10 SQL statements, like which I should run like one after the other. So can I just provide that SQL file and you would like run all those queries one after the other, like as a stream?
The question is, if I provide 10 queries, will they run in sequential order? They're going to run kind of in an asynchronous manner. I think the file will execute from the top down, but it's not going to wait for completion for each one. It's like, because these are persistent queries, they just stick around. So it's going to be like boom, 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 boom. Your streams exist now, and they're just being processed in the background. Yeah.
So, I mean, I know I've heard of, KSQL, but I'm not too familiar with it. And the notion of this persistent query being a query running against perhaps a window on a stream. One of the things that I've run into in the past is that, in tracking down a bug, you can roll back your code to a certain Git commit. But rolling back your data to that same time is a difficult proposal. Has anyone sort of thought of the idea of, well, I mean, can you, because this is all based upon topics and streams, can you move your stream back in time, sort of back to an earlier offset, if you will, and maybe it's actually a different query. Maybe you're replicating the same type of query on at a different time. You see what I mean?
I think I understand. The question is, sometimes we roll back code, but it's not quite so easy to roll back our data. So if you are a client and you have an offset that's at some position, is there some way to reset it, essentially? I think, let me attempt to answer this. I think each client is going to have its own unique view of the stream. Every client is going to have its own position within the stream where it's currently at. And even if you roll back a software version, that's not going to change, as you say. And so short answer is no, I don't think there's any way to deal with that out of the box. I think Nick has something to say here. Please help me.
Yeah, there is a tool called Kafka Streams Reset Tool. It allows you to rewind all the input topics for a given query, either to an absolute offset or to a relative time. So like 28 minutes ago.
Right.
You just reset all the state.
The bug was caused by a certain set of data.
Yeah.
Okay, interesting.
And I'll just restate that in case we didn't hear. That there is a offset reset tool ships with the streams framework, so you can roll back to a point in time, which isn't quite the same as rolling back to a Git hash, but maybe that's better than nothing. I don't know.
No, that's pretty good.
Cool. Anyone else?
And how frequently do you run these SQL queries? Like, do you run this query upon each message, or like how does it?
That's a good question. I think I was curious about that myself at one point. I think there's like a 500 millisecond, I want to say, polling interval or something like that. Am I off there, Nick? Do you know?
I think the phrasing of your question maybe makes me think that you think the queries are getting issued, but they're not. Right? The query here, it actually compiles down to a whole bunch of Java code, which is just Kafka.
It's the Streams API.
Yeah, the Streams API. And it's polling the topics continuously. As soon as a new record appears, it will be pushed through the code that executes the logic of your query upon it. So you could think of it as a message at a time.
Okay.
So is there a limit on the number of queries that are being executed?
You are limited by the resources you have available. I think there's some discussion going on about placing a limit. If someone is using the CLI, for example, can they just keep stacking up queries and stacking up queries? There is no limit. I think there's some discussion around what a reasonable limit might be. I think in an individual KSQL application, you probably don't want to have more than like a dozen queries, because that's kind of like, you want these applications to be kind of short and sweet, really concise little bundles of logic. But as far as on each cluster, on each server instance, there isn't a limit today that I know of. Okay. Just your resources. Cool, thanks everyone.